Generation 2 shift lever position. Generation 2 uses two signals to confirm the gear selection. This is a gear by-wire selection system. It's going to use redundant signals. There are two signals to indicate a single gear selection: the horizontal movement and the vertical movement. Here we have two schematics. The Hall effect sensors is what's going to give us our signal. A Hall effect sensor is an electronic device that varies its output voltage in response to changes in magnetic field density. The sensors are used for proximity switching, position detecting, and speed detecting. We can use them to detect current, and we'll see that when we get to the battery control ECU. It's not a vane style operated sensor. When we look at a Hall effect for a crank sensor, we actually see that a gear, a toothed gear or a vane, affects that sensor's signal. That's not how it works. This is positional sensing, and what happens is when we select a gear, how far are we moving the Hall effect sensor, and so it's positional sensing, and it's going to be directly proportional to magnetic field strength. Let's talk about the vertical shift lever. On the left here we have a photograph showing you that the gear selection can be up or down. We can go up or down with this. Over here we show a drawing, and it's indicating that up or down can be up in reverse neutral, down in drive. It can be up in the home position or down in the B position. Here we're showing you a line drawing. The yellow components in this line drawing are the vertical and the horizontal shift lever components. The round shift lever component on the left is the vertical. The horizontal shift lever moves back and forth. The gear shift actually moves back and forth, and it can be in one of two positions, neutral or home, when we look over here, and the yellow part on the top is the horizontal shift lever. So when we talk about the horizontal shift position sensor, we're talking about that gear selection going back and forth horizontally. When we look at the actual the gear selection, it can be one of two positions. It can be here in the home position, or we can move it to the left, and now it's called the center or the neutral position. When we look at the schematic, we can see that main, called the VCX3, and the sub is called the VCX4. The main VCX3 has a battery plus supply. The sub VCX4 has a battery plus supply. And then the main signal is VSX3 and the sub is VSX4. And it is simply, when it's in the home position, sends a signal of 0.5 to 2 volts. When it's in the center position, it sends a signal from 3 to 4.85 volts. The hybrid controller receives the signal from the gear selector based from the signals determined by the driver's request. So when the driver selects the home position, we get 1/2 to 2 volt signal sent from the unit to the hybrid controller. When the driver selects the neutral or the center position, the unit sends out a 3 to 4.85 volt signal. And the vertical position sensor has reverse, neutral, drive, home, and brake. 4 vertical positions. The main is going to use a main and a sub, so it's going to use redundant signals, is a 5 volt reference, and that's VCX1, and the sub is VCX2. The main signal is VSX1, and the sub signal is going to be VSX2, and then the main ground is E2X1, and the sub ground is going to be E2X2. So when we're in the reverse position, the vertical selector sensor is going to send a signal of 4 to 4.85 volts. In the neutral or the center position, 2.5 volts. In the drive position, 0.2 to 1 volt. In the home or in the brake position, it's 0.2 to 1 volt. Now that's exactly what it was for drive. Brake and drive are the same vertical position. What's going to differentiate drive from the brake position for the computer is the horizontal selector. So we're going to have drive and a different horizontal voltage than we would for brake with a different horizontal voltage. So when we're in reverse, the hybrid controller is going to receive the signal from the gear selector, and that's going to be based on what the driver determined the gear should be. Reverse. 3 to 4.8 goes to the computer, and 2.5 for neutral, and of course the drive position is 0.2 to 1 volt, and if we're in the brake position, 0.2 to 1 volt, because that's the same vertical position. Both signals are going to be required for the hybrid controller to detect the driver's request. One from the horizontal, one from the vertical. So when he requests reverse, the verticals should be 4 to 4.8. The horizontal should be 3 to 4.8. The neutral or the center position, the vertical is 2.5. The horizontal 3 to 4.85. Now when he selects drive, the vertical should be 0.2 to 1 volt, and the horizontal 3 to 4.85. And in the home position, vertical 2.5, the horizontal 0.5 to 2 volts. And of course, the brake position, the vertical is 0.2 to 1 volt, and the horizontal 0.5 to 2 volts. Now you're going to use diagnostic trouble codes in order to diagnose this unit. It'll help point you in the right direction. P0705, transmission range sensor circuit. That's very ambiguous, we know. So you're going to try to pull up the information or the 3-digit codes to get more specific information about the problem. So if we have that code and then we look it up, for the 3 digits we get 571, signal below normal value, check for an open or short to ground in the main vertical shift signal. So we're talking about the main circuits, and we're talking about the vertical that we're going to check signal levels to identify the problem circuits. And we go to our charts. It's supposed to be 2.5 in center, in reverse 4 to 4.8, and in brake or drive 0.2 to 1 volt. And that's what we're going to check. We're going to check the power for the 5 volt reference, and we're going to check the ground to be under 50 millivolts. When we look at these information codes, our 572 signal voltage too high, and they identify that that's the VSX1 signal. Check for a short to higher voltage, or check for the 5 volt reference circuit. Compare readings to the signal chart for the signal VSX1, and that's what we're going to do. 5 volts indicates that the circuit is shorted to the 5 volt reference. And of course, a higher voltage indicates that the circuit is shorted to a higher voltage. A 573 signal below normal value, check for an open or short to ground in the sub-vertical signal. Now, you can see the value of the 3-digit information codes. It really points you to what circuit you're working on. Compare the reading to the signal chart for the VSX2. Check for normal 5 volt reference in the return circuit. The 2.5 in the center position, 4 to 4.8 in reverse. So we're doing the same thing over and over again, but with the charts we know what it should be when we move the gear selector. Check powers and check grounds. You know, it's a integrated unit. You're going to replace it if powers and grounds are good and it's not working right. Here's another example, 574 signal voltage too high on the VSX2. Check for a short to a higher than normal voltage circuit or the 5 volt reference circuit. Compare readings to the signal chart. We're going to do the same thing for the codes as we go through them. We're going to use the information handed out in this class what the voltages should be in the certain gear selected positions so we can measure them against actuality. A higher voltage indicates that the circuit is shorted to a higher voltage circuit. So as we go down, we can look at the different information codes, and using a voltmeter and/or scan data, we can determine if the code is accurate. If the code is accurate, there's nothing wrong with the ECU. You're going to have to fix the wiring, the connectors, or replace the gear selector unit. 575, signal below normal, value check for an open or short. The 577, signal below normal, check for an open or short. Once again, I hate to keep saying it, but this is not brain surgery. Just follow the information laid out in the class. We give you the connector, we give you the cavity, we give you the value when the gear selector is in certain positions. Now, here's 595. There is a difference between the signal voltage of the main vertical, the SX1, and the VSX2, the subsignal. Now, we're going to check for normal shift lever voltages. You can do this in scan data, or you can do this with a voltmeter. You're going to compare the readings is what you're going to do. The 596, there's a difference between the signal voltage of the main and the sub again on VSX3 and VSX4. Check the normal voltages or use scan data. And that's exactly what you're going to do. You're going to move the gear selector and you're going to use the charts to check to see if the voltage is correct. If it's not correct, you're going to look for wires and connectors. And if it's not a wire connector, it's the integrated vertical gear, vertical and horizontal gear selector unit. Alright, so both the VSX and the VSX should indicate the same voltage. And use the chart. I know I'm being redundant myself, but use the charts laid out in this class and move the gear shift selector position. Use scan data and/or a voltmeter so that you can determine if the signals are exactly what they're supposed to be. Alright, when we're dealing with that scan data, you can see we can pull up VSX1 and 2. We can pull up the shift sensor main or sub, and we can pull up the position and look at the voltages. So right away, you don't have to grab your DVOM and crawl up under the dash. You can begin by doing it with scan data and using these charts. Now, a special note here, the gear selector tells the hybrid to where to move the selector actuator, which as you can see is mounted down there on the transaxle. The selector actuator is mounted to the side of the transaxle, and it is a three-phase unit. If you have any questions about what three-phase unit means, please refer to the hybrid operation and diagnosing training courses, and you'll see where we talk about the three-phase motors. So this may not be a motor that spins around and around and around. This is simply a three-phase unit, explaining that. Now, other models aren't going to use Hall effects, just the Generation 2 Prius. So they're going to use discrete switches like the Prius 1. Use the signal charts in the manual and compare the actual readings to specifications. This is not really brain surgery, guys.